Linear programming is a technique to optimize functions. We want to maximize profit, minimize cost. A constant is the limitation to the problem, typically expressed as an inequality. So, if you have the number of nails on hand to build a chair, a feasible solution is that you could produce 0 chairs, but we can't produce negative chairs, and we're limited by the number of nails that we have. We can't make more chairs if we don't have any more nails. So you see how it's an inequality. We need to be greater than 0, but less than the number of nails that it would take to build a chair. Okay, so when we do this, we have steps that we have to follow. Number 1. Here we go again. We have to define the variables. Okay, define the variables. That doesn't mean let X be chairs and Y be nails. Let X be the number of chairs. Let Y be the number of nails. That did count off some on your test if you didn't do that last time. Variables. Number 2, we're going to state the objective. Number 3, we're going to find an objective function. Number 4, we're going to state the constraints in a product resource chart. Number 5, we're going to transform those into inequalities, and also remember that we can't have negatives. So we're going to have to add that X is greater than or equal to 0, Y is greater than or equal to 0, okay? Okay, ready? We're just going to take it one little step at a time before we start graphing. Okay. Hello Kitty owns a garden of 90 acres where she grows strawberries and carrots. The seeds for the strawberry cost $25 per acre, while the carrot seeds cost $45 per acre. Hello Kitty has budgeted $3,600 for seeds. The profit per acre for strawberries is $120, and for the carrots, it's $80. What is the optimal solution for Hello Kitty to maximize her profits? Okay, so she wants to plant a garden, right? And she wants to plant this garden with strawberries and with carrots. What she needs to know is what? If she's going to maximize her profit, what would she need to know about planting strawberries and planting carrots? We know the cost per acre. Yeah, strawberries cost 25 per acre. But if you're planting a garden and you want to make the most money on that, and you have seeds, right? What do you need to know before you just go in and plant? The total acres, right? Okay, well, we know that there's a total acre of 90. How many acres of strawberries we want to plant and how many acres of carrots that we want to plant. That's what we need to figure out, right? Because we can plant it all in strawberries, we can plant it all in carrots. But we need to know what of that and how, when I go to plant, what's going to maximize it. So how many acres of strawberries, how many acres are going to be carrots? So let X, and you'll get the hang of this, I promise. Let X be the number of acres of strawberries. Let Y be the number of acres of carrots. Okay. When we are, what is Hello Kitty's objective? It should be the last part of this sentence. What does it say that she wants to do? What's her goal here? Maximize the profit. That is your objective. That's part 2. Her objective is to maximize her profit. So now we have to write the function that goes with that. So look in there in that word problem, and where do you see any other numbers about profit in there? The profit per acre, right? The profit per acre, and X is the number of acres of strawberries. Y is the number of acres of carrots. But the profit is the money we're going to make on each of those acres, right? So when we read this, what is her profit for strawberries? 120. So 120 times the number of acres that we plant. This is my objective function. Okay. And then what's my profit on the carrots? 80. So plus 80y. The objective function does not have an answer, because we got to figure out what we put in for X and Y that gives me the biggest number. Okay. All right. State the constraints in a product resource chart. Constraints. Okay. Product resource chart. Like this. Okay. You can do here. Okay, so on the side, we write what her products are. What are her products? Strawberries and carrots. Sorry, I'm trying to look where I didn't put the answer for this. Okay, and what are her limitations? What's going to limit? Yeah, acres are going to limit her. What else? Her budget. Her budget. I'm not sure that's right. Because sometimes I turn my product resource charts upside down, backwards, so I want to make sure I'm doing it right for you. Acres. Budget. Okay. Hang on, I think I did do this backwards. I want my strawberry and carrot substitute. I'm sorry. So how many acres does she have total? 90. And what would we add together to get that 90?
The acres of, X and Y.
X and Y, right? X and Y would give me 90. Okay, the budget. What's my budget total? 3,600. Okay, I got it. What is my budget for strawberries? 120. No, that was my profit. Where's my budget? 25. The strawberries cost me 25 per acre. And the carrots cost me how much? 45 per acre.
You said 45 per acre?
Love it. Okay, so now if we look at this, we've got some inequalities that we can write. Okay, X plus Y has to be, do I have to use all the acres? I don't. Right, so I could say X plus Y has to be greater than 90 or less than or equal to 90. Less than or equal to 90. So now we're transforming into inequalities. X plus Y must be less than or equal to 90. Okay, I have $3,600 that I can spend. The strawberry seeds are 25 per acre. The carrots are 45 per acre. Can I spend less than or equal to or greater than or equal to 3,600? Less than or equal to, good. 25x plus 45y has to be less than or equal to 3,600. Can I have a negative number of acres? Of strawberries. What about of carrots? No, so both X has to be greater than or equal to 0. Could I plant 0 acres of one of them? Sure, I might not want to plant any of them. They both have to be greater than or equal to 0. So those are these non-negative constraints here. Can you have a negative number of acres? No, we can't. So it has to be, they have to be greater than or equal to 0. Okay. All right. Now we need to figure out the solution to those problems right there. Okay. So these are gonna be bigger graphs, so we may just have to label these, right? All right, so this one's my blue. I know, I hear the big sigh, I do it too. All right, when X is 0, what's Y? 90. When Y is 0, what's X? 90. Okay. So 90, 90. It's a solid line. We're gonna test it. 0 is less than 90.
Yes.
Yes, okay, so this gave me a test point that's true. Okay, now we'll look at the other one. Anybody got a calculator handy? When X is 0, what's Y? When y is 0, what's y? So she's just doing 3,600 divided by 25. Okay, so over 0 up 80. And over 144, wherever that might fall. 0. Okay, and then we have y is greater than 0 and x is greater than 0 to keep it in quadrant 1. So for my test point for the blue line, I got 0 plus 0 is less than or equal to 90, 0 is less than or equal to 90, and that was true. So I shaded the blue side towards the blue line towards the test point of 0, 0. Good so far? Do I need to slow down a minute? Anybody need me to slow down a sec? We're good? Okay, good. All right. Test point. 25 times 0 plus 45 times 0 is less than or equal to 3,600. 0 is less than or equal to 3,600. True. So we're going to shade this test point side of the red line. Okay. Here's where Desmos comes in really handy. So what this means is the corners of the shaded area are all our possible solutions that we might check into our objective function. Okay, so that means I need to know this point. I need to know this point. I need to know this point. And I need to know that point. Those are the corners of my graph. So this is a corner at 0, 0. This is a corner at over 0, up 80. This is a corner at over 90, up 0. This corner right here, we would have to use substitution and elimination to find that. I have already tested you on substitution and elimination. Okay? On your test, I will provide you those corners. On your homework, they don't. So I want to show you up and above in Desmos how we can do this. Okay? I have to do it again. All right, so I'm going to just graph these lines. That's x plus y is less than or equal to 90. Does everybody know? Has everybody used Desmos before? Okay. Less than or equal to 90. Okay, so I shaded that one. And then makes my x1 25x plus 45y. Don't forget your x is greater than or equal to 0. And y is greater than or equal to 0. Enter. And I'm going to zoom out of this. All right, so there we can see the corners, right? You can see it better. So here's where all the overlap is in this right here. We need to know this point right here. If you just click on it, yes. Did I type something wrong? No. Huh? If you just know it's there, yeah, you can just do that. This point right here, everybody write it down in your paper. 22.567.5. Okay, and we're gonna use these with our objective function to see which one gave us the biggest number, which one maximized the profit. And I know that's gonna be suspenseful for you for Hello Kitty's garden, so I hope you can hang on to that suspense until Monday, because it's time to go. Okay, y'all gonna have to help me remember these points right here. This is big. I know this is big. I know this is hard, but I also know people have done it in the past. You can do it too. Okay, the hardest part is getting this. Put your pencils point up for me.
Oh, right.
Maybe did you?
What was
No,
that?
I'm good.
Yeah.
Yeah, I think I changed. Okay, so, we were dealing with Hello Kitty and her acres, right? And we had an objective function of 120x plus 80y. We got the points, but we didn't substitute them in yet, did we, in this class? No, we just have the points of the graph. Okay, so I was looking at the test for this unit. There is one where you do have to find the point of where the graphs overlap, so I'll make sure I go through that with you. But for the most part, you're going to use Desmos because it is just substitution elimination that we've done before, but there's only one set of lines where you have to find where they overlap. But in this one, we found that the corners of that shaded region for Hello Kitty looked, I think, something like, there was a corner here and here. So we had a corner at 0, 0. We had a corner at 90, 0. There was a corner at, was it 0, 80? And then we had this corner here that was 22.5.
7.5.
Thank you. And we use Desmos to find that, but I will teach you how to find that corner by hand, because you will have to do that. All right. So what we do is we want to figure out where she's going to maximize. It's only the corners of the shaded region that are either going to give you your maximum or your minimum here. So we make another little chart, basically. And we put in those XY corner values, and we put in our profit function, or our objective, objective function. I think I hit record. Oh, I did. And then we'll have our total here. Okay, so our corners are 0, 0, 0, 80, 90, 0, and 22.5, 67.5. Okay, so what we want to do is substitute those in for the X and the Y of our objective function. So our objective function was 120x plus 80y. So I'll do the 0, 0, and then we'll split up the rest. 120 times x, which was 0, plus 80 times y, which was 0. And that gives me 0. So her profit there would be 0. If she planted 0 acres of carrots and 0 acres of strawberry, her profit is going to be 0. Okay? Now, I'd like from the first two rows, would you guys do the 0, 80, and somebody from your first two rows come in and put up the answer. And then these two rows, do the 90, 0, and then my back two rows, would you do the 22.5, 67.5? So you're just putting the first value in for x and the second in for y. That when you're unhealthy. Yeah. Okay, you need a calculator for that, so get your calculator if you don't have one. When you got the answer, come put it in. And somebody's got your two row answers, so somebody can put in your answer for your two rows. You only have to do one math problem, the rest of the class is doing the other two. Go, let's go, let's go. You had the 0, 80. One more, my middle group, come on, can do it. Okay, copy down the rest of those answers. Those are all right. Sure why y'all won't come to the board, this is 8100. Okay, so those are the different options we have for maximizing her profit. We want to maximize it. That means we want to look for the largest number. So which one of these points maximized her profit? The 90, 0. Okay, this maximized profit. And so what that means, remember X was our acres of strawberries and Y was our acres of carrots. She needs to plant 90 acres of strawberries. And 0 acres of carrots to maximize a profit of $10,800. Any questions on that one? Okay, so we're gonna jump down, we're gonna skip the Sylvester problem and skip down to the music festival problem, okay? That's the whole thing, all 5 steps worked out from what we continued from class on Friday. All right. A college student is organizing a music festival that features 2 types of bands, rock bands and jazz bands. There are 2 stages, the indoor stage and the outdoor stage. The maximum amount of time available on the indoor stage is 420 minutes, and the maximum amount of time on the outdoor stage is 624 minutes. Each band needs 10 minutes on the indoor stage and 24 minutes on the outdoor stage, while each jazz band needs 12 minutes on the indoor stage and 16 minutes on the outdoor stage. So we want to find define the variables. We want to figure out what the objective is here. And we want to find the objective function here. Okay, a college student is organizing a music festival that features 2 types of rock bands. Okay, so there's 2 types of rock bands. And this doesn't give you really enough information of what he wants to do. He wants to get the most bands that he can get, okay, at the same time. And so these jazz bands and these rock bands need to share different indoor and outdoor stages, okay? So we want to let X be the number of rock bands he can get. And let Y be the number of jazz bands he can get. Okay. His goal here is to maximize the number of bands that he can put on the stage. And they each have their own restraints, okay? So find the objective function. The objective function is to maximize the number of bands, and X is the number of rock bands, and Y is the number of jazz bands. What's my objective function going to be? Add them. Yeah, X plus Y. That would be like a first a question on the test. It would stop there. I'm not gonna make you do one whole big question at one time, because you gotta get lost in the whole process when you do it all at one time, with all 5 steps. So it's just gonna be, it's gonna state like, give me these 3 parts to that question, okay? So turn the page and we'll look at another one. Let's drop to that one with the picture of the graph there. Okay, so let me. There's one very similar to this on the graph, on the test. So our goal is to minimize our objective function 2x plus 5y. And then we have this graph, x is greater than or equal to 0, 2y is greater than or equal to x. X plus y is greater than 3. 2x plus y is less than or equal to 10, and y is less than or equal to 6, okay? Some of these corners may be harder. What's wrong? Megan, did I do something funny? No, okay. Some of these corners are going to be harder to find than others, okay? So some of them we may have to solve for, and some of them may be obvious. Usually our corners on the x and the y axis are going to be pretty easy to solve. So there's 2 on the y axis. Can y'all tell me what those 2 corners are? Over 0, up, how far? The first point.
3.
3. Raise your hand if you don't see that, over 0, up 3. Okay, what's the corner of the shaded area above that? 6, so over 0, up 6. Okay, and then we see another corner there, and it has a y-intercept, that graph has a y-intercept of 10 and an x-intercept of 5. Do y'all see that line? It goes like from here, 10 and 5. Which line is that? What equation is that? Of these equations, which equation did that come from?
2x.
Yeah, this 2x plus y, so this is 2x plus y is less than or equal to 10. And it intersects with that horizontal line at 6, right? So which equation is the horizontal line at 6? Y is less than or equal to 6, right? So we need to figure out what that point actually is. Where's the point where they intersect? So we have y, and I think of these as equal to 6, and 2x plus y is less than or equal to 10. How could I figure out where they intersect? Substitution or elimination? Which one's going to be easiest for the first time ever? Substitution, because we know the y value, right? What is the y value? 6. So we're going to substitute 6 in here. 2x plus 6 equals 10. I substituted this into this. 2 and subtract 6 from both sides. 2x equals 4. Divide by 2, divide by 2. X equals 2. So that's the point 2, 6. Now, some of you are going to want to guess on your test, but if it's an intersection that's not on the x or y axis, then you need to actually solve for it. Yes.
Make sure we got the green juice.
It is this point right here and this point right here. And then we just solve for this one. Anybody else need to come show you? All right, let me show you on the board. Okay. that sort of look like what's on your paper?
Yeah.
And then this is the area that's shaded in. Okay, so what I did, this first point right here, number 1, I could look at my y-axis and see this point is over 0 up 3. Okay, so that's the 0, 3. And then this point right here is over 0 up 6. Okay, this one, that the way they figured out this was this line was because this value was at 10 and this value was at 5. And see how if x is 0, y is 10, and if y is 0, x is 5. So that this line was this 2x plus y is less than or equal to 10. And then this is just a horizontal line at 6, so that has to be y equals 6. Does that make sense? Everybody? So far? Okay. So we found that intersection is 2, 6. On the test, again, you're going to want to guess where these points are. There's going to be one you have to solve for, just one, but the rest will be at places on the x and the y axis. Okay, then we have this point right here. So this one looked like 3, 3. So which line was that? If it has an x and a y intercept of 3, 3.
X plus Y.
Everybody agree that's x plus y equals 3? And then this one. Going to 0, 0. This one, if you look at this one carefully, sorry, it goes to 0, 0. It starts at 0, 0, and if you count the slope, it has a slope of up 1 over 2, so it has a slope of 1/2. It goes through 0, 0. So the y-intercept is 0, and the slope is, yes.
Did you say that point was 3?
This one, this one.
That the bottom one.
This one is 0, 3.
Would it be 2? Like it goes.
Number 2. Oh, I haven't found this point. I'm trying to find this point right here.
Wait, what's that reading?
This point right here is 3, 0. This point right here is, so here's your 0, 0. Don't look at this being your 0, 0. This is 0, 0. So this point right here is over 0, 3. Does that make sense? And then we're trying to find this point.
Okay.
Okay.
I'm still wondering.
Who else? No, everybody else is good? Okay. Okay. This guy right here has the y-intercept of 0 and the slope of 1/2. Because we would have to divide by 2 to get that y by itself. So this is the intersection, this one right here, this slip line right here is this 2y equals x. Okay, so now we want to find the intersection of those two lines. X plus y equals 3 and 2y equals x. What's the easiest way to solve this one? Substitution or elimination? We know what x is, so probably substitution. Okay. All right, so I'm going to substitute 2y in for x. So 2y plus y equals 3. 3y equals 3. Y equals 1. Did I do too much in my head? Do you need me to? Anybody need me to work that out and show more steps to that? No? Okay. So y is equal to 1, and then we take that, we plug it back into either of the two equations. 2 times 1 equals x, so x equals 2. So that's the point 2, 1. Megan, you okay? Okay. So that's another point of intersection. Okay, can you look at the graph and tell me what this point is? We won't do the substitution and elimination again, but can you look at that one and tell me what that point is? This one right here.
4, 2.
4, 2, okay. 4, 2. So these are our corners. When you're doing your homework, you may use Desmos to find those corners, or otherwise it's going to take you way too long. But on your test, you will have to find one corner by hand, okay?
This one?
The others you'll be able to see from the graph. There'll be one that you have to find by hand using substitution or elimination. We're gonna practice that in just a minute. Yes. Yeah.
What's the point of doing when it's not by this, if you can just look at the graph and say it intersects to 1?
Yes, this one you can look at it, but on your test, there's one question where you can't look at it. So I was just trying to show you how we would do it if we were to just look at it. Okay, yeah. This one was drawn nicely, but I was just I'm trying to get you each step at a time, okay? All right, so now we're gonna take these and we want to minimize, our goal is to minimize, so here's our objective function, 2x plus 5y. Figure out in your groups what the answer is. You can split up the problem, so if you have 1, 2, 3, 4, 5 people in your group, it'll be really quick, everybody can do one. If you have 2, each of you take 2. And do one more. Figure out which one of those minimizes that function.
Okay.
Don't, and sometimes on the test, somebody on the test last semester, a couple of people actually just said, well, this one's the minimizing point because it's the smallest one. Do not do that. I promise you, it will give you the wrong answer on the test if you do that. Okay? Don't just pick the lowest point. You got to substitute them in, each of the values in for x and y, and see which one gives you the smallest answer.
By the time, I didn't work on someone.
It's,
I mean, I know where it's at, but I'm not sure, you know, I have to money. Yeah. No, from all the kids.
3
From all
sections.
these what is gonna give us this number?
you need to work.
February 24th. So next, a week from today is your test on.
That's what she did this.
Wednesday, I think it's Monday.
The next elected, what you said?
Monday, yeah, we can do that.
So we
Oh,
did
yeah,
X
sorry,
plus
you
Y.
got it, you need extra.
this one.
Yeah.
So we got a picture.
Is those
That,
slopes of-
what? You got an extra one? You need one. Okay, what, Megan?
X plus Y equals 3 is the slope of one.
You mean the progress?
And then 2y equals X is the slope of the
Yeah,
next
three
one.
exams and a
That's when
final.
she used
No,
elimination. It's like one
Yeah. If you take it on Monday, I can get it graded. I have to put your midterm in on Monday. It does nothing, really. Doesn't tell you much of anything. You got one test in? Nobody sees that, right? Then go. And I probably won't have 3 tests, because I have 3 classes of this on Monday. I probably won't have all of those graded to put in. So your grade right now, plus the homework you're gonna do will probably be your midterm grade, your progress report. Did everybody get one of these sheets that I passed out? Because this is gonna be one whole problem. From start to finish.
Oh.
No, I'm gonna go over this.
Oh, I have 4.
Put the answers to this on the board. So it's
What she said.
Everyone who's hungry. Okay, everyone's candy. That's fair.
This was an actual.
Everybody agree? Did you get it right? So which one's the answer? 2, 1. 2, 1 minimized it at a value of 9. Okay, that is a question, just like that on the exam. Here's the corners. Which one minimizes it? Which one maximizes it? Don't make it harder than it is, going.
Is it always gonna give us the constraints?
No, you'll have to find them in some of them. You'll have to do a product resource chart for one of them. We're gonna work through one of these problems from start to finish right now. That's what I just handed you. Question?
I was gonna say, so. It is gonna give us the lowest point, we can check it's all already.
It's not necessarily the lowest point. The one on the test is not.
Okay, that's what I'm, I was.
Yeah, this one just happened to be.
Okay.
Yeah. So don't just go, oh, I know it's the lowest point.
Well, yeah, I'm just
Yeah.
just definitely do it, that's why I was asking.
Yeah.
It's just gonna be the lowest one, solve it, or if it could be different. That's what.
It could be different, yes, yes. All right, so this is a problem from start to finish of a linear programming. Let me find my stuff. Which is the first one? Start of school. All right. With the start of school approaching, a store is planning on having a sale on school materials. They have a surplus of 600 notebooks, 400 pens, 300 folders in stock, and they plan on packaging it in 2 different forms. A fun pack that contains 3 notebooks, 1 pen, and 2 folders, and a writer's pack that contains 2 notebooks and no folders, and 2 pens. Each fun pack will sell for $6.20, and each writer's pack will sell for $4. Complete the following steps to use the method of linear programming to answer the question, and how many of each pack should they put together? Okay. Where's the question? What's the question in here? Where do we see it? How many of each pack? Underline that, because that's what gives us our variable. How many of each pack? Okay, so how many different types of packs do we have? 2. Those are our 2 variables. How many means the cost of each pack or the number of each pack? The number. So let X be the number of, I don't know, make sure, yeah, fun packs. Let Y be the number of writer's pack. Okay, so that's defining the variables. Look for the question. What is the question asking you? If you see a per or a for, like per acre with the Hello Kitty, that's your hint to remember per means that's where we put the variable. So it means the variable has to do with something like that. They could have written this where it said, sell for $6.20 per pack. And that would have helped you come up with that variable. If that's not there, then are you asking for where I am? Okay. I like these, the other questions that are on your notes. I had AI makeup and they kind of work, some of them work kind of weirdly. That's why a lot of those questions were, I like these better. Okay. All right. So that helps you define your variables. What is the objective? The objective in words. So look for the words maximize or minimize. Where do we see it? At the end. And what are we trying to do here? What's the objective? Great. Give the formula of the objective function in terms of two variables. So where do we see revenue or the amount that we're putting in the cash register? Where do we see that in the problem? Yeah. Yeah, the $6.20 and the $4, right? That's what they're collecting for those packs. Once we've used those numbers, just take a light pencil mark and mark through those because we don't want to use them again. So it was $6.20 for the fun pack, which was X, plus $4 for the writer's pack, which is Y. Remember, there's no answer. It's just kind of a statement there that we're using, and we're going to plug in the values to get the answers of what maximizes that. All right. So now we got to make the product resource chart. Okay. So we've got our fun pack and our writer's pack. So it's our variables that go on top and a total. And then we have our restrictions on the outside. So, or constraints. What are the things that we're limited by, or what are the resources that we're using to make these packs? Huh? Louder. I just couldn't hear you. What are we using to put these packs together? What are the resources? Yes, pens, notebooks, and folders. Okay, so these are the resources for our products. Well, we probably have a total number of these things. What's our total number of pens that we have?
4.
Good. What's our total number of notebooks that we have? Okay. What's the total number of folders that we have? 300. Once you've used those numbers, kind of cross them out because we've used them now. Okay. Now we're going to focus on the pens. How many pens do we have in the fun pack?
1.
How many pens do we have in the writer's pack? How many notebooks do we have in the fun pack?
3.
And in the writer's pack?
2.
And folders in the fun pack?
2.
And in the writer's pack?
2.
Okay. Now, Can we use more than 400 pens? Can we use less than 400 pens? Can we use 0 pens? Can we use a negative number of pens? No. Okay, so now we have to write out our inequalities. And fun pack, remember, was our x. So 1x plus 2y has to be less than or equal to, because we could use exactly 400. Okay? 3x plus 2y has to be less than or greater than? Less than or equal to. 3x plus 2y has to be less than or equal to 600. Two x plus 0y has to be good. Now, the one that people forget when they're doing the test is that we can't have negatives. So the number of fun packs that we create has to be greater than or equal to 0, and the number of writers packs that we have to make has to be greater than or equal to 0. Are we good so far? Does feel okay so far? Okay. So now we're going to graph our lines, okay, on the back of this page. Can I read this part of the board? So let's color code here. Okay. When x is 0, what is y? Okay. When y is 0, what is x? Remember, you're just taking this number, dividing it by the coefficient. Okay, so over 0, up 200, and over 400, up 0, and we have a solid line. The line's kind of wavy, solid line. And when I graph this, I'm going to label what line that is on it so that when I get ready to do my substitution and elimination, and I'm just going to put equals 400. Okay. All right. Good so far?
Yep.
Ready to move on to the next line? Okay, again, in standard form, 0, 0. When x is 0, y is 300. When y is 0, x is 200. Okay. Over 0, up 300, over 200, up 0. Okay,
So
So-
0? That one?
it's okay, so when X is 0, we're dividing by 0 and 0 is undefined, right? So this is really just the line 2x equals 300, right? If we take out that 0y, so this is kind of a weird one. Okay, and so if I divide by 2, I get x equals what?
150.
Remember that when we have x equals something, what kind of line does that make on a graph? Vertical or horizontal? Which one is impossible, right? Because we would be dividing by 0 if we divided by the y. Is that a vertical line or horizontal line? Vertical. It's a vertical. The x value is always 150. So we go to the x at 150 and draw a vertical line. Another way to remember that is our form is usually in the y equals, so the y one is the function, is the good one. All right, and then we have our x equals 0 and or greater than or equal to 0, and our y is greater than or equal to 0, so that's building that fence around our quadrant 1. Okay, so test point. Now I gotta figure out which way to shade. So test. We're gonna test 0, 0. It's not on any of those values, right? So 0 is less than 0 plus 0 is less than or equal to 400. True or false?
True.
True. Okay, the next one. 3 times 0 plus 2 times 0 is less than or equal to 600. So 0 is less than or equal to 600. True. Here we have 2 times 0 plus 0 times 0 is less than 300. 0 is less than or equal to 300. True. So they're all shading towards the 0, 0. So this comes this way, this comes down, this comes down. Do y'all see that the part that's going to be all overlapping by all of these guys is that area right there? Yes, no, maybe. Does that make sense to everybody? Okay, so some of the corners we have, right? So compute the exact vertices of all the feasible region. All right, so our corner points. Off the screen. Our corner points. Do we know this corner? What is it?
0, 0.
0, 0. Do I know this top corner right here? Over 0, up 200. Do I know this corner right here? Over, 0. Okay. So I need to find this corner right here. And I need to find this corner right here. Okay. This one right here is going to be pretty easy to find. Because what is the X value of that corner? 150, right? Because X is always 150. So we can go to this green equation and do 3 times the 150 for X plus 2y equals 600. Okay, because I knew that the X was 150. I could go ahead and substitute it in for X. Solve that. That's 450 plus 2y equals 600. Subtract your 450 from both sides. 2y equals 150. Divide both sides by 2. And y equals 75. So that guy, this point right here is when x is 150 and y is 75. Now, before you leave, would you write this down? Because we're gonna have to do one more problem, but it's gonna be the hardest one of all of them, okay? And that is where this blue line and this green line overlap. So on your paper, would you write 3x plus 2y equals 600? That's my green line, and my blue line, x plus 2y equals 400. Because when we come back to class on Wednesday, that's where I'm going to start. So do you kind of see now why I was saying, even though we saw those points on the last graph, why I was showing you how they're going to solve to get those corners? Okay. On your homework, to solve for these corners, I do not mind if you use Desmos because it's going to take you way too long to find those corners by hand for all the problems that are there, okay? All right, so we had the corner point 0, 0. We had 0, 200. We had 150, 75 that we found, right? And then we had 150, 0. That sound right? Okay. And we had a graph that looked somewhat like that. So we found that corner, we found that corner, and we found that corner, we found that corner. Now we have to find this corner, okay? On your homework, you can use Desmos to find that corner, but don't use it so much that you don't know how to find the corner for the exam, because you're not going to be allowed to use Desmos, but the homework will take you too long if you sit there and try to find every single corner the way we're going to do it. But just make sure you do a couple of corners with the homework when you do this, okay? So the corner points were this line right here going down and this line going down across. Those were the two lines that we needed. This is where your color coding really, really comes in handy, because if you write the equation in that color and then you graph the equation in that color, you know that's the equation of that line. So that line was the 3x plus 2y equals 600 line. And the x plus 2y equals 400 line. Okay, those were the two lines that made that corner. Everybody with me? Everybody see why it's those two lines that made this corner? When you look back at your paper, it's probably labeled better than my board, but those two lines. Okay, so I write those two equations up. Guess what I got to do to find where they intersect? Substitution or elimination, okay? Substitution would be easy if we solve for the x. Elimination would be easy because these are both 2y, so we just need to change the signs in one of those, or we can multiply the second equation by -3. So 3 choices there that wouldn't be that bad to do. I chose, bless you, to multiply the bottom one by negative or change all these signs. So I thought that was the easiest way for me. You pick your easy way and see if we get the same answer. So I left the first equation alone. And then I changed all my signs here. But if you like substitution, do substitution. Get that x by itself. It's not gonna be any harder to do that. So go ahead. I did make the quiz for you too, so that is in there, and I think it's due Friday. I think I put in at midnight. So. Get one variable, you have to substitute it back in, and get the other variable. Yeah, substitute that back in and solve for y.
Negative one to all negative.
It doesn't matter.
Either one cancel out until you like.
When you use substitution, you have to alter the elimination. Okay, so why would you do it with that? Because X is already by this, you get a combination going on. You got to have you want to use substitution. So if you want to use substitution, don't get the Y, it has a number in front. It'd be X.
Okay. Thank you. Sorry.
When you change these signs, that makes that a negative X, a negative 2Y, and a negative 100. So these have the same sign right now, we need them to be opposite, so you need to change all these signs in this equation. And that's going to be 2X equals 200. Question. Okay, I got 100, 150. If you didn't get that, raise your hand. Let me come and get your paper so I can help you with it. And that's what you're working on, make sure you get it. Okay, so that's the point of the other corner. That would be negative. One more second to finish up. Okay, so that gave us all the vertices. We found all the corners. At those corners, you're either gonna have your maximum or your minimum. They will always occur on one of the corners. So sometimes I have students that go, oh, my lowest corner is gonna be my smallest, and my highest corner, wherever you choose the highest, is gonna be my maximum. That is not necessarily true, and I promise it's not true on your test, okay? So don't just think you can look at it and tell where the maximum or the minimum occurs. Now, back on the front page, we had our formula, our objective function that we wrote in number 3. And that objective function was the revenue function, R of X, Y, because we had X and a Y, was 6.2X plus 4Y, right? Remember that? That was the price of how much they were selling the fun packs and the writers packs. And the goal here was to maximize the revenue. So what we do is we take each of these corners, 0, 0, 0, 200, 150, 75, 150, 0, and 100, 150. And we substitute the X in for X and the Y in for Y. For each of those. So 6.2 times 0 plus 4 times 0 is equal to 0. I did the first one for you. Okay, so after that, you guys do the rest. 6.2 times 0 plus 4 times 200, 6.2 times 150 plus 4 times 75, 6.2 times 150 plus 4 times 0, 6.2 times 100 plus 4 times 150. We're substituting the corners in to our objective function. Okay? If it has all the answers, you can come up and fill in the totals for each of those points for me.
Well, this was. So we do that. The place in the y-axis, the x-axis, and any points in the intersections. And 0, 0.
Thank you.
Hits here. Right, get those numbers? Yeah.
Yeah.
Okay. So Max, look at your paper because you circled the wrong thing there. Which is the biggest number? 1230. Our goal was to maximize. That means we picked the largest one. So then we have to write what it means. It means we sell 150. That's our X. Remember, X was the fun packs. Fun packs. And 75 writers packs to maximize profit of, or revenue, excuse me. Wasn't it revenue? Was this revenue or profit? Revenue. Revenue of $1,230. Yes.
When we show our work, do we have to use that chart?
Yes.
Okay.
Any questions? Okay, everybody get into a group of 2 or 3 or 4, however many you like to work with, 5, whatever. But nobody be by themselves for this one. I want you to start on this next problem, and every now and then I'm gonna stop and put a few answers on the board and explain just to make sure you're going in the right direction. So start off with doing your 1, 2, and 3. Before you go much past that, let me check it and make sure that we're in a good place to keep going. Okay, 1, 2, and 3 would be one question on the I'll switch it. Would be one question on the test. All right, and don't back up. You're going to back up into it.
Okay.
Okay, get in a groove. Come on, get in a groove. Grant, are you in a groove, Grant, over there? Okay. So I just want to say this one time to the whole class as a whole. So when we're defining our variable, you find that question mark. Let X be. And the question mark says how many production runs at each plant. That will help you get it. So let X be how many or number of production runs at Macon. Let Y be how many. Get it straight from the question marks. Jonesboro. And y'all all did a great job of finding the objective in words. It says to minimize cost. Again, in that question mark. Objective. Minimize cost. Objective function. It's about cost, and I've probably been lax on doing this. So C equals, And then we're looking for the cost. So where do we see anything about costs there? $600, and that was at which plant? Macon, and what was the other cost? 1,000 at which plant? Jonesboro. So 600X plus 1,000Y. Go ahead and just lightly cross out those numbers with your pencil because you're not going to use them again and you don't want to get mixed up with what you've already used and try to use it somewhere else where it doesn't belong. Okay? So if we've gotten to that part, go ahead, set up your production resource chart. Remember, it's going to always be, for me, 3 columns because we're only going to deal with the with 2 variables. Some of the ones in your book, if you go to practice extras, have 3 variables. I don't make you do systems of equations with 3 variables because we can't graph on a 3D plane. Okay, so we've got on the tops, we have our Macon plant and we have our Jonesboro plant. And then we're looking for some totals. So how many rows did y'all make when you made your production resource chart? 3. Okay, go ahead, keep filling that in for me. Okay. Resources that they're using at these plants to make this. LP, MP, and HP. Okay, so what's the LP for the Macon? 1, and the LP for Jonesboro is 1. Okay, I see this a lot because y'all just said, oh, total, add them together. Don't add them together. Get the total LP from up here. What's the total LP? 100. Okay, what's the MP from the Macon? I don't know that I hit record. Oh, it is. 2. The MP from the Jonesboro. 5. And what's the total? Good. Okay, and then HP Macon. HP Jonesboro. And total HP? 180?
180.
Okay. All right, now, so from here we can write our inequalities. I'm just going to do it here. And I'm going to, this is where I start color coding, so for my graphing. So 1x plus 1y. Now, if the customer needs this much, can he have less than it? No, he has to have that much. Can he have more than that? Yes. So this is now greater than or equal to 100. Okay. When we see minimize, usually it's going to be greater than. If you see maximize, usually it's going to be less than, just to kind of keep in the back of your head. Okay. And so then we have 2x plus 5y greater than or equal to 260. And we have 3x plus 1y greater than or equal to 180. What else do I need to have in here? X and y are both what? Greater than or equal to 0, because we can't have negative production runs. Okay. Go ahead and graph those. It'll be easiest to graph them using your X and Y intercepts, but you graph them how you like to graph. Okay, so I've got my points, I'm gonna graph my lines, over 0, up 100, over 100, up 0. Over 0, up 52, over 130, up 0. over 0, up 180,
And where we are now.
over 60, up 0. Okay, what's,
Yeah, you're.
what's wrong, India?
Oh,
Yeah, you're.
Okay.
Like a plate for.
Yeah. Alright, and then we've got our X and Y is greater than 0, so that's those lines, keeping me in quadrant 1. So now we need to pick a test point for each of these, and I pick 0, 0 every time if I can. Okay, and plug in 0, 0 for X and for Y and see if you get a true statement. Guys, if it's in standard form and you plug in 0, 0, you're gonna always get 0 over here. So you don't have to bother with your time. 0 is greater than or equal to. Paul, bless you. 0 is greater than or equal to. False.
Right here.
0 is greater than or equal to. False. So here's my test point. So all of these get shaded away from the test point. Don't come towards it, go away. Okay, and then really kind of darken in where they all overlap. Just trace that line down. And it's everything to the right there. So all I do is trace that line down from where it starts and keep moving towards my outside line. Okay? So I have 1 corner, 2 corner, 3 corner, 4 corner. How many of those are going to be nice, easy corners to figure out? Huh? Just the ones on the X and Y axis. That means we have to do substitution and elimination twice, okay? I do give you one question where you have to figure out where the intersections are. Okay, so what was this corner right here? Over 0, up 180. It was on my green line, so that tells me I'm going to my green line to look for that. Now, this one was on my red line. So what's that one? Over 0, or over how far up 0? 130. 130. Okay. So for this corner right here, it's mine. I don't know what color is yours. It's my green and blue line. So I'm going to use those two equations. And this corner right here is my blue and red line. So I'm going to have to do substitution or elimination with my green and blue, substitution elimination with my green and blue and red. Okay? So keep going with that. About where we're okay, so there's 4 corners. We've got a corner point here, a corner point here, a corner point here, and a corner point there. 4 corners that bound that area. How many are easy to find?
2.
2 are easy to find. What do we have to do to find the other 2? Substitution or elimination. Okay, so let me erase this and see if I'm still on the recording. All right, so This corner right here, what is this corner? It came from the blue line. You see it came from the top of the blue line over 0 up how far? 180. So I got 0, 180. Okay. And this corner right here is easy to find. That came from the red line. Okay, that's my x-intercept. So which one is that? So 130, 0. Okay, you with me so far? Now, this is where the color coding comes in handy. This intersection is my blue line and my green line. So I'm going to take my blue equation and my green equation, and I'm going to write them together. I've got 3x plus y is greater than or equal to 180, and my green line is 1x plus 1y, and I'm going to write this as equal to, equals 100. I'm going to write it as equal because I'm using elimination. I'm using the intersection of the lines. The other intersection comes from my green line and my red line. So that means I'm going to write my green line and my red line together. My green line, again, was 1x plus 1y equals 100. And my red line is 2x plus 5y equals 260. Again, this is the part that I'm talking about on your homework, that if you need to use Desmos so it doesn't take you 5 hours to do it, to find those corners, use Desmos. But on your test, you're not going to be able to use Desmos. You have to use elimination or substitution to solve these. So go through and see, why don't we simplify this? Why doesn't from Courtney, these two groups right here, why don't you guys do the elimination for these two equations? And those two groups right there, you guys do the elimination and substitution for these two equations, and then we'll help each other with the answers to the one that we're not doing. Okay? So if I'm looking at this, if I'm doing substitution, if y'all prefer substitution, we want to get one of these variables by itself. If you're doing elimination, we can even just multiply, since we got y over y, we can just change the signs in one of the equations. This one, if you do substitution, we want to solve for one of these variables up here. If you do elimination, you either want to multiply this green equation by a -2 to make it change the sign and be the opposite of this, or a -5 to make the y's eliminate. Either one, okay? But then once you find one of the variables, substitute it in to find the other variable. Okay, I'm going to do them both up here, but you guys just do your one problem. I'm going to do them both by elimination. And I think it's easier to multiply one of the equations by -1. Even if you did it another way, you should still get the same answers as me. So raise your hand if you need me to come look at your work, if you got lost somewhere in there. And you're graphing these, so you can even kind of tell, does that look like the point where they would intersect? Does that look about where you should be on that graph? Looking at anything, I see a lot of squinty eyes, like you're trying to figure out what I've done up there. Yeah, this is the answer to number 6 on your paper right here. You've lost track of where we're working. Right down your work for the second one, you need to copy the second. That, then we can go to that last step of making the chart with your corner points and your objective function and see which one minimizes your cost. Okay, so these are the values you're going to substitute into your objective function to see which one minimizes. So that's the last step of the problem. The last piece of the question. I'm just gonna set it up over here so that for those of you that are ready, just take your time. Oh, actually, I want to do that. Notice it wouldn't have made sense, bless you, if I had gotten a negative answer here because I was in quadrant 1. So keep that in mind. If you're in quadrant 1, we shouldn't have any negatives there. Okay, so you take your corners, substitute them into your objective function. Then just put that into your calculator, get those totals. And the last test, somebody would just go, oh, this is the lowest point, so this is the one that minimizes it. Don't do that. You have to substitute it in. That is not the one that minimized it, right? So we substitute those in, get the answer, find the smallest one in this case, because we're trying to minimize. Okay, and we minimize. It was to minimize the cost by 80 runs at Macon, 20 runs at Jonesboro, for total cost of $68,000. Okay, so this is actually a skill that's used in business when you're using maximizations and minimizations. In medicines, where you want to maximize the most medicine that you can give someone with a minimizing the whatever the side effects, something like that. This is actually one of the more useful techniques, especially if you're a business major, that you do use an applied math here. Okay, does anybody have any questions? All right, so these problems take a long time. So on Friday, I will record our review session, okay? But I'm gonna have to go pretty quickly. So you may have to go back and watch the video and slow it down for you, okay? Because I want to be able to get through the whole review. That's important. But I will record it so that you can then go back if you're like, oh my God, you totally lost me there. You can go back and slow it down and take it piece by piece, okay? So review on Friday, test on Monday. If anyone's planning on being at the testing center for your test, please let me know now so I can let them know that you're taking a test there next week. Okay? And that's if you have approved accommodations.